Hello and welcome to another Python game making for beginners tutorial. So in this one we have some really exciting stuff coming up. We're going to do our first full game with graphics, controls, the whole 9 yards, using the Python Arcade module. So there are a couple of prerequisites that you'll need before we get into this one. You will need to have Python installed, and you will also have to know some basics of the Python language all the way up to and including at least the very basics of object-oriented programming. You have to know about classes and functions, as well as the basics such as variables, how to do math, string formatting, things like that. Thankfully, I have you covered on my Python for Beginners series. I will link to that playlist above. Be sure to check that one out. And also check out the Intro to Python Arcade, where I show you an introduction to the Python Arcade API by drawing a forest scene with primitive shapes using procedural generation. I will also link to that. So on this one, we're going to do a 2D, two-player space shooter, kind of reminiscent of Space Invaders, but with 2 players on either side of the screen, which I'll show you in just a moment. I was inspired to do this one by the YouTube channel Tech with Tim. He has lots of great stuff. Please check his out. And he did a game that is similar to this one, but he did it in Pygame. So I wanted to see if I could do the same kind of thing, but do it in Python Arcade. So I'll go ahead and show you what our finished game is going to look like. Let me run my test project. Here we go. So we've got a title screen, pretty simple, space shooter, press enter to begin, and then we press enter, and we have a blue ship on the bottom, which can be controlled with the left and right arrow keys. I've got my red ship at the top, which can be controlled by 2 other keys, and then the left shift controls the red ship's lasers, and the blue ships is controlled by the right shift. And if one person takes 3 hits, then we go to a game over screen. We can hit enter and play it again, and it lets us know who wins. So very, very basic game, but this is going to be a great introduction to making games with Python, and specifically with Python Arcade. So this is what we have so far. I've already got my project set up. So let me navigate to my project folder. So I've got the 4 graphics. I've got my blue laser, my blue ship, my red laser, and my red ship. I also have a space background. I actually have 2, but we're only going to use 1 of them. And I have my title screen. So my ship and laser graphics came from Kenny.nl, KNNEY.nl. He's a great artist and has offered actually quite a few 2D graphical art assets for free, so be sure to check him out and make a donation if you're so inclined to do that. And then I have my title screen, which I created myself. I threw that together in Photoshop in like 2 minutes, which is why it looks not great, but you know. But I'm also going to have these assets, including my title screen and my space background. That one I pulled off of Google Images. You can do a Google image search. If you do that, just be sure you find something that is labeled for reuse with modification if you plan on distributing your game to other people, even if it's for free. Be sure that it has that kind of license. So I have all of those. You can ignore my other space background. That is the archive that had all my graphics in it. You can ignore that. And then I've got 2 scripts. You will only need 1 Python script. I have 2 different versions of it because one of them we're going to do a little bit more of an advanced extension, but we're going to start off with just the most basic one, basically without the title screen and without the title screen and the ending screen, and then I'm going to show you how to add that at the end. But I've got 2 different scripts just to show you both of these different methods. So what you are going to need is just 1 script. Mine is called 2-player space game, separated by underscores. And let me go ahead and pull up my project real quick, and we will jump right in. So the first thing that we have to do is we've got to do a couple of imports. So we're going to import our arcade module, and we're also going to say from OS import path. So the OS is the operating system module that's included in Python. If you use it, you do have to import it, but it will come with your distribution of Python. And we're going to use that in order to help Python Arcade find our graphics assets that we're going to be using, because we're going to create a variable that points to our home directory, which I'll show you how to do in just a moment. All right, a couple of other things we're going to need is we're going to need a few different constants. And actually first, since I mentioned that, I'm going to go ahead and do my directory constant, and I'm going to call that dir. This is just going to point to the directory that has our module or our game in it. So we'll be able to point Python Arcade to our graphics. And we're going to say path.dirName, and then in parentheses, path.abspath, that stands for absolute path, _file, _. It's kind of a mouthful. I won't go into all the specifics of what this does, but basically this creates a system agnostic directory to find our files. So we should be able to run this on Linux, Mac, or Windows, and it should be able to find our directory, even though they use slightly different formatting as far as their directory paths. All right, after this, we are going to need two scaling constants. So we're going to do Sprite Scaling players, and right now we're going to set that equal to 0.75, and then we're going to do Sprite Scaling lasers. So the reason that we need these constants, by the way, since they're constants, I'm going to put all of these as capital, all caps in the variable declaration. You don't have to do that, but that is a common convention in Python, so I highly recommend you do it just to keep everything consistent. So what this is going to do is the graphics we're going to use are just a little bit too large for what we're going to be doing. So by setting our sprite scaling as 0.75, we're going to scale them down to 75% of their regular size. Like most of these variables, you can play around with them a little bit and try your own values and see what you can come up with. You might like the bigger sprites, you might want them even smaller, but I do recommend having both of these at the same level though. All right, after that, we're going to do player 1 max health and player 2 max health. So this is just the maximum number of hits you can take before you lose the game. Then we're going to do our screen size. Our screen width, we're going to set at 1000 pixels, and screen height, we're going to set at 800 pixels. Again, feel free to change these values if you want. I recommend using my values in the beginning, but once you get your game up and running, you can try some different values if you want. All right, after that, I'm going to set a screen title that is going to be 2-player space shooter. And that's just going to be the title that's going to show up on our window when it's open. After that, we're going to say player speed, which is just how fast we're going to move. And we're going to set that at 5 pixels per frame. And then laser speed, we're going to set that at 10 pixels per frame. So that basically means that our lasers are going to move twice as fast as our player does. And then after that, I'm going to set a winner. I'm doing this lowercase because this will change. And right now, winner is going to be none. So those are our global constants that we're going to be using. All right, after that, we're going to create our first class, which is going to be called myGame. And that's going to inherit from arcade.window. And this is going to be our main application class. So this is basically where our game is going to live, all of the initialization. And speaking of initialization, the first function that we're going to create in there is an Initializer Function. And I'm just putting some doc strings in here just so we know what everything does. Let me clean that up a little. There we go, make that a little further away. All right. And this is going to call the parent class initializer. So it's going to call that arcade.window initializer from Python Arcade. So it's going to take care of some of the behind the scenes stuff for us. All right, and we're going to call the initializer now with super parentheses dot double underscore init double underscore, and we're going to pass it three different parameters. We're going to pass it the screen width, as you can see up there. It's going to expect an integer, so we're going to say, oops, we've already declared that as a constant, so we're just going to put in screen width and screen height. And by declaring these as constants, if we decide we want to change any of this later, all we have to do is change the constant up at the top, and we don't have to go through our code and change absolutely everything. And it's going to look for a title, and so we're going to call that, oops, screen title. There we go. All right, so after that, we're going to create some lists. And lists are how we keep track of the different type of objects in our Python arcade games. So we'll get more into what these mean in just a moment, but we're just going to, let's see, variables that will hold sprite lists. So yeah, these are just going to be the different types of objects in our game, and this is later going to allow us to determine how they interact with one another. So we're going to create self. So we have to use the self identifier because we're referring to this specific variable in this myGame class. So self.player1list equals none. Self.player2list equals none. Oops, and I was getting an error there. I was trying to figure out why. This should still be indented because this is going to be in our initializer class. That was my mistake. Then we're going to do self.laser1list equals none. And again, we're just creating these as placeholders right now, so we aren't really going to place anything in them just yet. We're going to do that elsewhere in our code. So later on, the player 1 list and player 2 list are just going to hold our player 1 ship and player 2 ship, respectively. The laser lists are going to keep track of the lasers that we fire. So the player 1 list is only going to have player 1 in it, and the player 2 list is only going to have the player 2 character in it, the player 2 sprite in it. But we still have to create them as list because that's what Python Arcade expects. We're also going to have a wall list. Later when we create our game physics, it's going to expect a wall list even though we aren't going to use walls. We could put walls and that just lets us know that those are things that we can't pass through. But again, we aren't going to use it, but we have to have that because it's going to be passed as a parameter later on even though we aren't using it. All right, next thing we're going to do is set up our player info. So we're going to do player 1 sprite. And again, we're just initializing these variables right now. Not actually passing anything to it at the moment. We're going to do that in the next section. We're going to do our health for each character. There we go. And then we're going to set up a variable for our background image, which, as you may have guessed, we're going to initially set that to the value of none. Then we're going to tell Python Arcade not to show our mouse cursor while the game is going. And that's very easy to do. We just say self.setMouseVisible. There we go. And we're going to pass that the parameter of false. All right, and that's it for our initializer function. The next thing we're going to do is create a setup function. Now, you might be asking, why didn't we just put all of our setup function, all of our setup stuff in the same function? The reason why is that this is just basically a good practice to get into with Python Arcade. If we want to create different levels later on, then we can create a different setup function for each level. Like, they're all going to have these same basic variables, or most of the same basic variables, which we're going to declare in the init, the initializer function we just did. But then we can have a setup function for each individual level. So we're going to go ahead and do that now. Finish setting up these variables and determining what actually goes into them. So this is going to set up the game and initialize variables, because some of these values might change from level to level if you have different levels in your game. So the first thing we're going to do is to load our background image, and we're going to say self.background equals. So again, we declared that variable up here and set it to none, and now we're actually going to pass it a value. So we're going to say arcade.loadTexture, and we're going to use an F string here, string formatting. So we're going to say F. Again, check out my earlier videos if you don't know how to do that. And we're going to pass it our directory variable, and then a double backslash. Again, one of these backslashes is an escape character, so it's going to be name of our directory, and then backslash, and then we're going to put in the name of our background, which mine is called space_free.png. And again, if I go to my File Explorer here, you'll be able to see that there if you're using VS Code. It's pretty easy to find. So just put in the name of your variable, which may be different than mine, or you can rename it. Whatever you choose to do. All right, that's all we do for our background. Next, we're going to create our sprite lists. So, and basically we're just going to pass these an empty sprite list object. The sprite list object is included in Python Arcade, so it knows how to handle everything, a lot of things behind the scenes. So player1 list equals arcade dot sprite list. All right, and I'm just going to copy that because this is going to be the same for every single value that we pass, that we create for every list. Self.playerList equals arcade.spritelist. Same thing for the laser1 list. Laser2 list, and then last but certainly not least, the wall list. There we go. Then we're going to set up the players. So we're going to give them a max health value of our max health constant. Self.p2 health equals p2 max health. Then we're going to pass it our sprite images. This is going to be the images that represent our players. All right, and again, we're going to have to use our directory constant here. So we're going to say, oops, go back up there. There we go. Self.player1 sprite equals, and then we're going to use an arcade.sprite object, and then we're going to pass it, first of all, our file name, which we're going to do pretty much what we did before. Pass it the directory, double backslash, and this one is blue_ship.png. So let's pass that in. And then after this, it's going to expect another value that is our scale. And so this is where we put in our sprite scaling before. So we're going to say sprite scaling players for that one. And that's going to scale it down to 3/4 of its normal size. There we go. And then we're going to do self.player1 sprite.center x. So this is going to tell us where to position our sprite at the beginning of the game when we first start. So our center x, we want to put it in the exact middle of the screen, which our screen is going to be 1,000 pixels wide, like we put in before. So I could just say 500 pixels, but again, that'll mess things up if we decide to change our screen size later. We'll have to go change all of these variables. So it's best to do this with math. So I'm just going to say screen width divided by 2. It's easy as that. Very, very simple math. Then we're going to set our center y. Self.player1 underscore sprite.center y. So this one's a little bit different. This one we're not going to set a relative size, but we're going to set it a certain size from the bottom of the screen. And for player 2, we're going to set a certain distance from the top of the screen. So when we do this one, when we set our players, I'll give you a very brief overview of the Cartesian coordinates very quickly because I went over this in my last video, which you should check out if you haven't. But we have an x-axis and a y-axis. But on Python Arcade, the 0 point is at the bottom left of your screen. So if you put your finger at the bottom left corner of your screen, that is 0, 0. If you travel to the right, that increases the x value, and then up increases the y value. Left decreases the x value, down decreases the y value. So it's just like the Cartesian coordinates you did in math class when you were in school, except our 0 point is not in the middle where we usually think of it, but at the bottom left of the screen. If you've used other game engines or graphic programs, you might be used to a different system where the 0 point is at the top left of your screen and positive y values go down. Again, Python Arcade does not do it that way, even though most software does. So what I want to do is I want to place our player 35 pixels up from the bottom of the screen. So I'm just going to set our center y to 35. So even if we resize our screen, that 0 point on the y-axis is still going to be at the bottom of the screen no matter what. So it's always going to place this the right value, even if we change our screen size later on down the road. It's not going to be true for player 2, but we'll get to him in just a moment. All right, the next thing we need to do is we need to add it to our list by using the append method. So self.player1list.append, and we're going to add our player1 sprite to that player1 list. All right, and next we're going to do basically the same thing with player2. I'm going to take a shortcut here. I'm going to copy all of this. Oops. Paste it right down here. We're going to change blue ship to red ship. We're going to leave our center X at screen width divided by 2. We want him right in the center. However, we want him to be 35 pixels from the top of the screen. So we're going to say screen height minus 35. So screen height minus 35 pixels is where our player 2 is going to be. And next, I'm going to show you a really cool shortcut you can do with VS Code. If I click to put my cursor somewhere, and then if I hold down my Alt key, every time I click, it'll add another cursor. So I'm just going to add a cursor everywhere I have player 1, and then I'm just going to go backspace and player 2. And to go back to one cursor, just click somewhere on the screen or hit escape, and that'll go back to normal. There we go. That was pretty easy. All right, after that, we're going to set the background color, which you don't really have to do since we're using a background image, but it's a good habit to get into, though. Oops. So we're going to set the background color by using arcade.setBackgroundColor. I love Python Arcade because all of the functions and objects are really easy to remember. There we go. And the last thing that we have to do here is we have to create our physics engine. So this part gets a little bit weird because we have to create a physics engine for each one of our characters. So we've got to create a physics engine for player 1 and a physics engine for player 2. So we're going to create a couple of variables. Oops, first, create the physics engine. And Python Arcade has, I think, 3 different physics engines, one of which is called Physics Engine Simple, which is the one that we're going to use. So Physics Engine Simple, basically you can move up, down, left, right. You can do basic things like shoot like we're going to do, and that's pretty much it. You can bump into walls. So think like our top-down shooter, or if you do a top-down game like, you know, Gauntlet, or like a lot of the top-down roguelikes that are popular right now, like Streets of Rogue, stuff like that. You could probably get away with using Physics Engine Simple for those. There's also a Physics Engine Platformer, which, as you might guess, is for platformer games, where you can add gravity and ladders and things like that. And there's also one called the PyMonks Physics Engine, which adds advanced physics to where objects can fall, they can bounce, they can do different stuff like that. So I'm going to look into doing some videos on those in the future, I hope. But for now, yeah, we're just going to stick with our Physics Engine Simple. That's going to serve our purposes just fine. All right, so we're going to create 2 new variables. Self dot, if I can type, physics engine 1, and that's going to be arcade dot physics engine simple, and then it's going to expect the object that we're applying the physics engine to and the things that it can bump into. Like I said before, we had the wall list that we had to declare before. If we don't pass that in, this won't work. We'll get an error. So self.player1sprite is our player object, and then self.walllist is our list of walls. Then we're going to do the same thing for player 2. Self.physicsengine2 equals arcade.physicsengine simple. Self.player2sprite, and again, self.walllist. There we go. All right, next we're going to go ahead and set up the framework for the rest of it, just so you can see where we're going before we get into the rest of the code. But that's pretty much sets up the game. We've got our initializer and our setup function. So the next thing we're going to do is our onDraw function, which is going to draw everything to the screen every frame. Then we're going to set up our controls with, oops, I didn't mean to put all that in there. We're going to use all that stuff. That's going to be on key press, and I'm just going to set all these to pass right now. Then we also have to figure out what's going to happen when we release our key. Otherwise, if we just hit left, we'll just keep moving indefinitely until we press a different direction. So we're going to say on key release, and I keep on letting it put in the boilerplate, which we aren't going to need all of that stuff. Oops. There we go. And then we're going to create our update function. Did it again. And actually, let me go ahead and put in our doc strings and whatnot where they are applicable. So onDraw renders the screen. There we go. And then update, this is going to contain our movement controls, or our movement functions rather, and game logic. All right. And that is just about it. Aside from that, we're just going to create our main function. And then our if name is equal to, main, then we're going to run the main function. So if you've never seen this if name equals main thing, basically that's just saying that if this is the main script that is being run, then go ahead and run the main function. Otherwise, if we call this as a module, then it will not run the main function. But right now, all of our code is going to be included just in this one script. Later, we'll look into doing things with more scripts included in one game, different script files, and that will become more relevant then. But again, it's good to get in the habit of putting that down there. All right, so under our main function, we're going to create a variable called window. Set that equal to my game. That's going to be our main game window. Then we're going to call our setup function. And then we are going to run our game. So let's run this real quick and see what happens. I'm not even sure if anything's going to happen. Oh, and yeah, something did happen. It opened our window and then closed it real fast. Just like in the last video. That's pretty much all it does for right now, until we tell it to do a little bit more. So let's go ahead and take care of our onDraw function so we can try rendering the screen and maybe see some graphics in a minute. All right, so the first thing we have to do is we have to start the render engine. So we're going to say this command has to happen before we start drawing to the screen. All right, and that is arcade.startRender. All that does is it just starts the render engine. Next, we're going to draw the background image. So we're going to say arcade.draw. Again, this is a built-in function, LRWH, rectangle textured. Okay, so what this is, it's going to call a texture, basically just an image file, which we have stored as our background image. And it's going to look for the bottom left X, the bottom left Y, the width, and the height, and then the name of our texture. Those are the only things that we're going to use right now. So our bottom left X and Y are going to be 0 and 0, because we're going to start at the very bottom left of the screen. So that's our bottom left X and bottom left Y. Next, our width is going to be screen width, because we're going to do the whole width of the screen. And then our height is going to be screen height. And then, yes, okay, there we go. And then after that is going to be our background image, which we stored in a variable a moment ago. That is going to be self.background. There we go. And that is all for our background image for right now. All right, so let's go ahead and run that and see what we get. Oh, it didn't like something. Give me just a moment. Oh, it didn't like the fact that I called update with no arguments. So let me go ahead and comment that out. I don't know if this will work or not if I comment out the update function, but let's give it a try. Yeah, there we go, it did work. So there we go, so now we've rendered our background to the screen. Excellent. I'm going to go ahead and leave that commented out for right now, just so we can check everything else as we go along. So after we draw the background, we have to draw the sprites onto the background. So there's a very good reason also we drew the background first. It draws everything in the order that it's encountered in the code. So if we draw our player sprites first, it's going to put the background on top of them. And we want to do the opposite. We want to draw the background, then put the sprites on top of the background. So that's what we're going to do right now. So draw all the sprites. All right, so now we're just going to use our lists that we've created, self.player1list.draw, and that's all you have to do to draw it to the screen. Self.player2list.draw, and then we do our lasers, laser1list.draw, and laser2list.draw. There we go. Let's see how that works. Excellent. So now we've got both of our players on the screen. One of our players is facing the wrong direction, and the other one is facing the correct direction, which we'll fix in just a moment. And we don't see any lasers yet because those lists are still empty. We're not gonna create those just yet. Oh, also something else you'll notice is that my mouse cursor disappears when I go over the screen, just like we did that in our initializer function, I believe. Yeah, there we go. All right, so we're not going to fix our Player Two Sprite just yet. We'll do that in a minute. For now, we're going to go ahead and draw their health level on the screen. And so we're going to create a variable called P1, a couple of variables, P1 health text. And we're going to use our string formatting again. So we're going to create a string called P1 lives. You could call this health if you want. I think I call it health in the code, but lives on the screen. It's all right. And then we're going to put P1 health in the curly brackets, and that'll render that variable to the screen. Then we're going to say arcade.drawText. This is the function that's actually going to draw the text to the screen. And it's going to look for a couple of parameters. The first parameter that it's going to look for is the actual text that we're going to be drawing. So that's going to be our variable P1 health text. Then it's going to look for a starting X value, like where the text is going to start. So we're going to put that 10 pixels in from the left side of the screen. And then it's going to look for our height. And I just realized in my reference project, I believe that I accidentally reversed this. So let me fix that now. We'll put it 10 pixels up from the bottom. And then it's going to look for a color. And again, our Python Arcade has a bunch of colors built in, so you can just call arcade.color white. And then it's going to look for a font size, and we're going to do an 18-point font. There we go. Excellent. And so this onDraw function, by the way, runs once for every frame. So ideally, it'll be running at 60 frames per second. So it's going to update every frame, and if anything changes in your health, it's automatically going to change that variable and redraw that to the screen. So that's how it dynamically tracks your health, because it's constantly running this entire function 60 times every second, ideally speaking. All right, so we're going to do the same thing for player 2. P2 health text equals P2 lives self.p2 health. There we go, that should all be correct. Yeah. And then again, arcade dot draw text. We're going to say P2 health text. And we're also going to set this one 10 pixels in on the x-axis. And we also want this one to be, actually let's do this one on my reference project. I did screen height minus 30. So it's going to be 30 pixels down from the top. I think I tried 10 and it didn't work. It was kind of cut off at the top. All right, same color, arcade.color.white, and 18-point font. There we go. Now if I run that, we should see our health on the screen. And we do. There we go. Yeah, P2 lives 3, P1 lives 3. So yeah, if I did that as 10, I think it would be cut off. Let's try that real quick, just for curiosity's sake, and see what that looks like. Yep, there we go. That's why I did 30. There we go. So screen height minus 30. And yeah, I know I keep saying this, but it took me an embarrassing long time to realize this when I was doing tutorials. But I don't magically know all of these numbers. Like, I had to play with them a little bit and try a few different values and find out what worked. And after you complete this project, do the same thing. Like, if you want to save a copy of it so you've got a fresh copy just as I created it, go ahead and do that. Or you can, download my code from GitHub. I'll be sure to put a link down to that below. You can also get my graphics there. But yeah, go in and break the code. Try different values. Try different things in there. Break it and then fix it again. And try, just like try your own values and kind of mess around with it and see what you can do. And you might find something that you like better than what I did. All right, so that is all of our drawing function. So now we get into the controls. This is where it gets into the fun parts. All right, so I'm going to get rid of this pass. And so our on-key press is going to look for 3 parameters. So we're going to do self, key, and modifiers. In the interest of full disclosure, I'm not entirely sure what modifiers does. I think that's like, for multiple key presses. I'll get into that later, I hope. The key is just going to look at what key you're pressing down. So that one's pretty simple. So now we're going to use a series of if statements to look at what keys are being pressed and when. So we're going to go and set up player 1 controls first. So for player 1, I've got it set up where he is using the left and right arrow keys to move and the right shift key to fire. So let's go ahead and set that up. So if key, and again, this is just our key parameter that we passed in there, if key is equal to arcade.key.left, all capital, then we are going to say self.player1 sprite. We are going to change his x value to a value equal to negative player speed. So what this is going to do, like I said, everything in this onDraw function, actually, yes, we're still in the, oh no, we're in the on-key press. Still, this is going to be tied to our physics process, which is going to be carried every 60 times every second, every frame it's going to run this. So every frame, we're going to move to the left, because we're saying negative player speed, we're going to move to the left by whatever our player speed value is. I think I set it to 5 pixels. So 5 pixels per frame. Again, higher numbers will be faster, lower numbers will move slower. All right, then we're going to say L if key is equal to arcade.key.right. See if you can figure out what we're going to do here. We are going to change that equal to just player speed. So now we're going to add values to the x value, meaning we're going to move right on the screen if we hit the right arrow key. All right, and next we're going to set up our firing mechanism. This is just a little bit more complicated, but not too bad, because we have to tell it to create a sprite every time we fire our laser. So we're going to create another elif key is equal to arcade.key.r shift. That is our right shift key. Then we're going to put in a nested if statement. Actually, oh, no, we're not. We're going to do something else first. We'll get to that in a moment. We'll take the easier route. We're going to say laser equals arcade.sprite, and then we're going to pass it our laser sprite. So that's going to be dir /blue laser.png. That is our first parameter, and then it's going to look for scale. So we're going to say sprite scaling lasers. And that is all we have to do for that right now. Under that, we're going to set our position, just like we did with our players. We're going to say laser equals, oops, I'm sorry, laser dot center x. And we're going to set that equal to self.player1 sprite dot center x. So this ensures that no matter where our player is on the screen, we're keeping track of that variable. So wherever our player is, whenever we hit the right shift key, it's going to create a laser exactly where that player is. And we're going to do the same thing for center y. Laser dot center y equals self.player1 sprite dot center y. And on this one, we're going to say center y plus 50. Think about it for a moment and see if you can think why we're going to put plus 50 there. I'm not going to tell you just yet. Actually, I'm going to go back and change that in a moment, and you will see why. Actually, let's go ahead and run that and see what happens. Oops, let me change that back. So now if I fire a laser, Oops, and sorry about that. I was looking for the key release. We won't be able to do that just yet. My mistake. I'll go ahead and tell you. So if we do that this way, it's going to create a laser sprite on the middle of our player sprite, and we want it to appear just in front of them. Again, I played this around a little bit with this a little bit and figured out that 50 pixels is a pretty good spot to put that laser. All right, the next thing we're going to do is we're going to set the Y value to change every frame. There we go. And it's going to be set equal to laser speed. So that laser is going to travel up on the Y-axis every frame, number of pixels equal to laser speed, which for right now, I believe I set that to 10 pixels. Then we're going to add it to our laser list. And we are just about to start working with our lists here in a couple of minutes, and you'll see why these are super, super handy. There you go. Actually, let me comment this on key release out and see if I can get that to work. There we go. Yeah, but the game immediately breaks. That's okay. All right, so far so good. Let me go ahead and, oh yeah, because I don't have the physics engine in there yet. Let me uncomment all of that. I think that's the last test run that we're going to do before we get our physics in there. All right, so I'm going to run through this next part a little bit more quickly. I could copy and paste, but I'm going to go ahead and type things out just so you can see it all step by step again, because we're going to do the exact same thing we just did, but this time we're going to set up the controls for our player 2. So our player 2, I've got it set up so that when you hit A, you go left, D is for right, and then the left shift is going to cause our red player to shoot. So if key is equal to arcade.key.a, by the way, if you want to try this yourself, feel free to pause the video, skip forward about a minute or so, and see how you did. Self.player2.sprite, player2sprite.change x equals negative player speed. There we go. Oh, one thing that's worth mentioning is I use a Dvorak keyboard layout. So my D key is not a D key, but it is an E key. So when you see E there, just know that my E is where your D probably is. And I picked the A and D specifically so I could keep with WASD controls, the WASD, that most people are used to anyway. There we go. Equals player speed. All right, if key is equal to, and this time we're going to do arcade.key.l shift for the left shift key. All right, we're going to use another F string. We're going to call dir double backslash red laser.png. It's going to look for this scale. Sprite scaling lasers. And all right, our X value. Oh, actually, never mind. Sorry about that. I forgot I put that in a different spot. We're not going to add it to the laser call variable there. All right, so we're going to do laser dot center X equals self dot player to sprite dot center X. That is correct. There we go. And on this one, since we're at the top of the screen going down, we're going to have to change that to center Y minus 50 instead of plus 50. And we're going to change Y. We're going to set that equal to negative laser speed, because again, we're traveling down, so we're going to subtract numbers along the Y-axis. And then we're going to append that to our laser list. There we go. All right, I think we should be pretty good there. All right, and then all we have to do is set our on-key release, because the way it is right now, if we hit our left arrow, we're going to move left, and then if we let go, we're just going to keep moving left. So we're going to set it to stop us if we stop pressing left. If key, oops. Oh yeah, I forgot to pass my parameters in. Let's do that. So we're looking for self key modifiers. If key is equal to arcade.key.left. Try to figure out what we're going to do here. We're going to set change x equal to 0. So now if we let go of our left key, we're going to move left at 0 pixels per frame, which is going to keep us stationary. Elif key is equal to arcade.key.right. So if we let go of right, exact same thing is going to happen. Equal to 0. Now here I am going to copy these two lines. We're going to do the same thing for our red ship, player 2. Except we're going to set that to, what did I do? A. And D, which again is going to be E, which is going to be D on your keyboard most likely. And then we're going to set that to our player 2 sprite. Remember, Alt-click. Let you select or place two cursors at once. There we go. That's all we have to do for that. That part is pretty easy. And then we're going to get into our update function. So this is where our physics are going to happen. So this one is going to look for two arguments, two parameters. First one is going to be self, just like always. And the next one is going to be delta time. So if you're unfamiliar with the concept of delta time, I won't get into a full description of what that is right now, but basically that calculates the time that has passed since the last frame. And basically this locks your programming to the frame rate instead of locking it to the clock rate. So if something happens that causes your system to slow down, your controls will also slow down. If you drop frames or anything like that, your controls should stay consistent. That is why we use delta time. Again, that's kind of a very, very quick and poor explanation of what that is, but that's the basic idea. All right, so the first thing we're going to do, again, just like the onDraw function, this one is going to be called every frame. Every 60th of a second, we're going to update our physics engines. There we go. And let me see if this will run now. I'm not even positive what will happen, but we'll give it a try. And hey, there we go, it works. Our top ship is still facing the wrong direction. Let's see if our lasers work. All right, the lasers do work, but we haven't yet applied physics to them. So that's not going to work. Oh, and I'm getting an error because I typed my file name wrong for my red laser. I put a space there. There we go. I like to debug as I go along just to make that stuff a little bit easier. So right now everything else should be working okay. All right, so after we update the physics engine, here we go. We call update on all sprites is what we have to do next. Self.laser1list. So again, we're going to update our laser lists. Let's see if that works. There we go. Now our lasers are working. Our red ship still is facing the wrong direction. I promise we will fix that eventually. So our problem now is that when we hit a ship, the lasers just pass right through it and nothing happens. So that's what we are going to fix in just a moment. This next part is not super complex, but honestly, probably the most complicated part of the whole program. And again, it's not that bad. So what we're going to do next is we're going to loop through each laser in that list. Again, this happens every frame. We're going to loop through the laser and see if it has made contact with one of our ships. If it has, we're going to destroy the laser, meaning we're going to make the sprite disappear, and we're going to subtract 1 from the ship's health that got hit. So we're going to start by creating a for loop. Let me put my comment first. Loop through each player 1 laser. And this is why we create our laser lists. It makes this a lot easier and more efficient. So for laser and self.laser1list. So the first thing we're going to do is to see if our laser has hit a player. So we're going to create another list called the hit list. And basically this is just going to create another list briefly that's going to determine if anything has gotten hit. So hit list equals arcade, and we're going to pass that, or we're going to create an object rather. which is check for collision with list. And we're going to pass that the sprite, then the sprite list. And again, we're checking to see if player 2 has been hit by player 1's laser. So we're going to pass that the player 2 list. There we go. So that's going to be our hit list. Then we're going to say if it did destroy the laser, this is pretty easy. If the list, if the hit list is greater than 0, meaning basically if something has gotten hit, then we're going to say laser dot removed from sprite lists. That's it. That's all we have to do for that. That is pretty easy. And if a player was hit, we're going to subtract 1 from player health. All right, so again, we're going to call our hit list for player in hit list self.p1 health minus, equals 1. So that just means we're going to take 1 away from the total health. If self.p1 health is less than or equal to 0, then we're going to remove the player from sprite list. So that's going to effectively destroy our player. All right, let's run that and see what happens. All right, so we got player 1. Yep, laser fires okay. We hit it once. Oh, it's removing lives from player 1. That is not what we want to do. We'll go back and fix that in a moment. What happens when I hit it? There we go. But the right ship did disappear, so that's good. All right, give me just one moment. I'm going to go and figure out why that is subtracting health from the wrong player. Oh, I think I found it because I did. That should be self.p2 health. There we go. Let's try that one more time. Again, debug as you go. There we go. Now the right thing happens. Very, very good. Okay, good. Now we're rolling. Let's see. Okay, so now we have one more problem. So if we fire a laser, it creates a laser, and if it hits the other ship, that laser gets destroyed. But what happens when it flies off screen? It's not necessarily out of sight, out of mind. That laser is still being tracked by the computer's memory. It's still keeping track of exactly where it is, just way off the screen, or off the bottom of the screen where we can't see it. So this is probably not going to cause any huge problems with this game, but if you have a lot of sprites going on, it can cause a memory overflow error, which can crash your program. It can crash your whole computer, actually. So always be sure that you destroy your sprites after they leave the screen, unless you intend on them coming back, which you probably don't. So let's do that part next. If the laser flies off, flies off screen, destroy it. So we're going to say if laser dot bottom, so basically the bottom of the laser sprite is greater than screen height, or laser dot bottom is less than 0. So if it goes off the screen in either direction, then we're going to, remove it from our sprite list. All right, that should be good. All right, now we're going to do the same thing that we did for player 1, but for player 2's lasers. And I'm not going to comment quite as much on this one. I am still going to go ahead and type this out, though. And then we're going to pass that our laser variable, our sprite list, which, let me remind myself which sprite list are we using here. Yeah, this is going to be self.player1 list. There we go. And, oh, I think that's all. Yeah, that's all we need. Okay, self.player1 list. we're going to destroy it if it hits a player. Yeah, some of this I could probably put in a function where I wouldn't have to type all this out. I may go back and refactor some of this and clean it up a little bit later. But for now, I am pretty happy doing it this way. Now we're doing self.p1 health minus equals, oops, 1. Self.p1 health is less than or equal to, I cannot type today. It's infuriating, so I'm a pretty good typer. Player.remove from Sprite List. What is your best typing time out of curiosity? My best time I ever got was 80 words per minute with 1 mistake. I only hit that one time. I averaged like 65 to 70. Yeah, let me know in the comments. I'm curious about that. Let me know what your best typing speed is. If laser.bottom is greater than screen height or laser.bottom is less than 0, laser.remove from Sprite Lists. There we go. All right. So let's check that out now. Player 2. There we go. But yeah, that can still happen. We'll fix that in a minute. And we're also going to have another problem here. I'll show you this real quick. You may have picked up on this, even though I haven't shown it explicitly, is that our ships can fly off the screen. Thankfully, they can come back, but if you hold down your button, they'll just keep going and going and going and going and going, and we'll never see them again eventually. So let's go ahead and fix that real quick, make it where they can't go off screen at all. All right, so we're going to say keep players in bounds. So basically, we're just going to use another series of if statements and say if the player starts, if their x value is too much or too little, make them not be that anymore. So if self.player1 sprite.center x is greater than or equal to screen width minus 50. So this is we're going to make sure we always keep them keep their center 50 pixels inside of the edge of the screen. Which again, I played around with these numbers and that just seemed to be something that worked pretty well. So if it tries to go above that value, or below that value rather, we're just going to set it equal to that value. So it's not going to let us go past that. Same thing with the positive 50 value. If self.player1 sprite center x is less than or equal to screen width. Oh, I'm sorry. Nope, we don't have to use screen width. We're just going to say 50 because that's going to be 50 pixels in from the left side, which is always 0. Self.player1 sprite.center x equals 50. There we go. All right, and then I'm going to copy this. Oh, why did that happen? There we go. And I'm going to use my Alt-click trick. That is one of my very favorite VS Code shortcuts. There we go, do the same thing for player 2. Let's go ahead and test that. Again, I like to debug as I go. There we go, we are quite good. Now, I think it is about time that we go ahead and fix that player 2 sprite. Let me see, and I believe we can do that. Let me find where my character sprites are. There's blue laser. Blue ship, there we go, it's under sprite images. Yeah, and it's actually really easy. So after you do sprite scaling players, there's an optional parameter called flipped vertically, and we're just going to set that equal to true. Boom, there we go. And that is done. All right, very, very good. And that is actually about it for the basics of the game. There are a couple of extra things we're going to do in just a moment, just to kind of flesh it out a little bit. But as of now, we have something that one might call a somewhat functional game. Hello everyone, Future Adam here, and as I was editing this video, I realized that I left out a somewhat pretty important detail. So there is a very minor problem with our game right now, at least I think it's a problem. It's not game breaking or anything, but you'll notice that we can just spam lasers indefinitely, and we can fire as many lasers as we want. For game balancing purposes, I'm going to limit the number of lasers that each player can have on screen at one time. So the way that I'm going to do that is we're going to create another global variable called max lasers. And for right now, I'm going to set that equal to 3. So this means that we're only going to be able to have 3 lasers on screen at one time from each player. So each player can have only 3 lasers on screen at one time. And the logic for that is going to go in the controls. So we're going to do under on key press. And let's look for our right shift. There we go. So right now, if you hit right shift, it runs all of this code, creates the laser, moves it across the screen, all of that stuff. So basically, we're just going to take all of this, we're going to indent that one block, and we're going to put this inside of an if statement. It's going to check our laser list to see if it is equal to or less than 3. And if it is, then it's going to let us fire our laser, otherwise it's not. Alright, so first thing we're going to do is we're going to check the length of the laser list. So we're going to say if length self dot laser1 list is less than 3. Let's say anything else what we want to do. Yeah, that should work. Actually, not. I'm sorry. We're going to do if it is less than max lasers. There we go. Oops. There we go. I don't like using so-called magic numbers. Like I use variables wherever possible, so I didn't want to do just less than 3. But we're going to set that to our max lasers variable. All right, and then the same thing down here for player 2. I'm going to indent that one block. If length of self dot laser2 list is less than max lasers, then I'll run the rest of that block. All right, now let's check this out and see if that works. There we go, and now we got 3 lasers on screen. I can hit as much as I want, and it will only let us do 3 lasers at a time, again, from each player. There we go. Now, back to the rest of the video. A somewhat functional game, but we're going to go into a very, very slightly more advanced topic, which is the idea of views. And this is how we can do a title screen and an ending screen, which we are going to do right now. So the first thing that we have to do, though, is we've got to change the way our program runs just a little bit. So I'm going to get rid of everything in our main function. We still are going to have the window variable. But now, yeah, we're actually going to call the window function down here instead of up at the top like we did before. And we're going to pass this 3 parameters. Oops, go away. What are you doing here? There we go. So we're going to pass it our screen width, our screen height, and our screen title. After that, we are going to declare a start view. And we are going to set that equal to title view. Don't freak out. This view does not yet exist, but it's about to. We're going to create it. We're going to say window dot show view. We're going to pass that start view. Then arcade.run. So basically, this is, yeah, creating our window variable. It's going to then call our, we're creating a variable called start view that is going to be title view, which is our title screen. And then we're going to show that view. And I'm going to show you how to do that right now. So we're going to go back to the top, and we're going to change one or two things, and then we're going to add some stuff. So now, instead of using arcade.window, we're going to use a view, and we're going to change my game to game view. So views are really handy for when you're switching levels, or like I said, if you want to add a title screen. It's literally just a different view, a different thing that you see. Let me see. I don't think we have to create any new variables. No, we should be pretty good on that. But we are going to have to create a couple new classes. We have to create a new class for each one of our views. So we're going to do a title view and then an end-screen view, which is going to show us who won the game and give us the option to restart. So class title view, we're going to inherit from arcade.view. This is the view to show the title screen. And we're going to create a function called onShow. We're going to pass that just the self variable that is required of all functions in a class. All right, and this is where we're going to declare our title screen. We're going to say self.texture equals arcade.loadTexture. And then we're just going to pass it that file destination, which is going to be dir / and, oh, what did I call my title screen? I've got it on my other monitor. Space shooter title separated by underscores.png. Again, if you want to use my title screen, check on my GitHub. I will post that in the comments below, or in the description below, rather. So you can check that out. You can get that as well as my complete source code if you want that to refer to. All right, so the next thing we have to do, we actually probably aren't going to do this in this one, but I'm going to go ahead and put it in here just because it's good practice, is we need to reset the viewport. So I'm going to put that in the comments just because I did that on my reference project. There we go. So set the viewport if necessary. If we have a scrolling game, there we go. Yeah, so you might need to reset the viewport back to the 0 point if you have a scrolling game. We do not have a scrolling game, but again, it's good just to put this in there. It's good habit, good practice. So arcade.setViewport. So our left is going to be at the 0 point. Our right is going to be screen width. Our bottom is going to be screen height -1. I'm trying to remember why I set it as that. But I'm not going to worry about it. I'm just going to put it down. Screen height minus... Oh, I'm sorry. No. I missed one. There we go. The bottom is going to be 0, and the top is going to be screen height -1. So we're going to do that 1 pixel down from the top, just to make sure it's on screen. All right. Very, very good. Next, we have to create an onDraw method, just like we did before, but for our title view. And this is just going to draw the view, as one might imagine. So arcade.startRender, self.texture.draw size. So this is how we're going to draw basically just one static image on the background. It's going to look for a few parameters. It's going to look for our center X, our center Y, and then our width, I believe. Yes, our width and our height. There we go. So our center is going to be the very center of the screen. So how do we do that? Screen width divided by 2. Screen height divided by 2. Then just screen width and screen height. Simple as that. And next we have to do a new set of controls, which are going to be a lot simpler than the controls we did earlier. But we're going to use the same kind of function. Def on key press. Same parameters as before. Self key modifiers. I think that's correct. Yes, it is. And so our enter key is going to be the start key, or our start key is going to be the enter key. So if key is equal to arcade.key.enter, then we're going to create a new, or we're going to reset our game view variable to be actual game view. We're going to run the setup function from game view. Then we're going to call our window.showView function and pass it the game view. All right. So that's all we have to do for our title view. We have one more view to create, and then we've got a couple of different things to clean up with our game view. But we're going to create our game overview. So this is the view that we're going to show when the game is over, and we're going to give the players an option to restart. View to show when the game is over. All right, and of course we have to create, or for this one rather, I'm sorry, we have to create an initializer function. So the reason we have to create an initializer on this one is because we're using a couple of variables. One variable in particular is dynamically created during our other view. That's going to keep track of who the winner is. So we've got to have an initializer function to keep track of who the winner is. That's why we needed one for this view, but we didn't for the title view, because we don't really need to keep track of any variables for that one. All right, so we're going to call our super initializer, just like we did for the original game view. Self.winner equals none. We're going to reset our background color. Again, I don't think we have to do this. Oh, actually, we do have to do this. Never mind, because we aren't using a background on this one. So we're just going to use a plain solid background. Oops. All right, and then we're going to reset the viewport just like we did before. And I'm not typing all that out again. I'm just going to copy and paste that from my reference project. There we go. Easy as that. It's just like we did before. All right, next we have to create our onDraw method or function. That's going to draw the view. All right, so we have to start the rendering engine. Then we have to draw text to the screen. So this one, I actually prepared this this project months ago and finally started to get ready to record this video yesterday. And they've since updated Python Arcade from version 2.5 to version 2.6, which changed the way that drawing text works. I'm still getting a handle on this. It took me way too long to figure out how to do this, but I'm going to try to explain this as best I can as we go along, because they've completely changed the way that text is handled. All right, so we're going to create an F string, and it's going to say game over. Then we're going to do \n. So this is going to create a new line. It's going to skip us down to the next line. We're going to give it our winner, self.winner wins. Then we're going to do another new line, and we're going to say press, oops, we don't have to put that in quotes, press enter to play again. Yeah, we are going to end parentheses, end quote. There we go. So that is our first parameter that we're passing in. There we go. After that, we're going to after that, we're going to pass in the position that that text is going to appear on the screen, and we want it to be in the center. So we're going to say screen width divided by 2, screen height divided by 2. We're going to pass in the color, color.white. The font size, we're going to use a nice big 35-point font. So the next thing we're going to do is we're going to pass in a couple of optional functions. We're going to anchor it to the center along the X and along the Y, and these parameters are passed in as strings. All right, then we're going to set the width as screen width. This next part is the one that took me forever. I couldn't get my new lines to work for the life of me, and I figured out is that when they changed it, you have to tell it explicitly that you're doing a multi-line string, or the new lines just won't work. Just won't do anything. Don't know why, but that is that's what it is. So multi-line true. Oops. Again, be sure you have that in there or it will frustrate you endlessly like it did me. And then we're going to pass in one last align center. Okay, that should work. We'll test it in a moment. All right, next we're going to say def. We're going to put in another group of controls on key press, self, key, modifiers. If key is equal to arcade.key.enter, just like we did before. This time we're going to set our game view equal to game view. This is basically, I believe this is exactly what we did on the title view a minute ago. Oops. We're going to run gameview.setup and then set our window show view to game view. All right, and I think we have one more thing that we have to do. Let me look for just a moment. We have to set our ending condition to call up this screen. Oh, and one more thing we have to do after that. Or let's go ahead and do this other part. Now, all right, again, this next part I could probably put in a function and it might make things a little bit cleaner, but like I said, I may do a video later where I go back and refactor some of this code and clean things up and add some features to it. But for now, I'm just going to do it the long way. Let's see, where's the part that I'm looking for? There we go, that's what I'm looking for. So let's subtract 1 from player health. So the last thing we had there is if player if self.p2 underscore health is less than or equal to 0, we're going to remove that player from the sprite lists. Okay, this is what we're looking for. We're also going to set the view equal to game overview. Game overview, rather. Oh, I actually got a little bit premature. You know what? I'm just going to start this part all over again. There we go. So when player 2's health is... Stop popping up. When player 2's health is released to 0, we're going to set the winner equal to blue player. We're going to remove that player from every sprite list that they belong to. We're going to set our view equal to game overview view.winner. So this is another important part that took me a really long time to figure out. By saying view.winner, our view is now game overview. So when we say view.winner, then we are going to pass this winner variable, which is this one. We're going to pass that to the winner variable in our view. That is how we're passing that who the winner is from this view to the next view. So when I was putting this together, that took me a really, really long time to figure out. A lot of research. All right, and then we're going to show the view. And again, we're going to do essentially the same thing when our player 2 dies. Let's see. Yeah, there it is. All right, so now we're going to say on this one, winner equals red player, player.remove from sprite lists, view equals game overview, view.winner equals winner, self.window.showView. We're going to change that to our view that we just changed. There we go. That should be pretty much it. There we go. Okay, we'll run it. There's our title screen. It says press enter to begin. We press enter and nothing happens. Give me just a moment and let me see if I can figure out what I did wrong here. All right, I got it figured out. So there's something that I forgot to change in my game view. So here we're calling the parent class initializer, and I passed it screen width, screen height, and screen title. So down here, it said the problem was in line 82, which is where that is in my initializer. It says it takes from 1 to 2 positional arguments, but 4 were given. The problem is that I already passed those arguments to my window here, so these are redundant. So if I remove these from the initializer, everything should work at this point. Let's try that again. All right, press enter to begin. Nope, and oh, now it's doing my, give me just a moment, let me figure this next part out. Oh, here we go. That was easy enough. So now I'm no longer using a window object. I'm using a view. So on my self.setMouseVisible, this is a property for the window, and I'm not in my window function. I'm in a view function, or a view class, rather. So what I need to do is say self.window.setMouseVisible false. And let's run that one more time. Let's see if that works now. All right, title screen. There we go. All right, and then let's have a player 2 win. There we go, game over. Red player wins. Press enter to play again. And there we go, we restart back to the game. And blue player wins. There we go. All right, so that is pretty much our 2D space shooter in Python Arcade. So is the game finished yet? Honestly, I don't know. I think there's more than we can do with it, and if you ask any game developers that are far more skilled and knowledgeable than I am, they'll probably tell you that a game is never really finished. Like, you've got to know when to call it quits at some point. But there are things that we could add to this, things that are probably pretty important. We could add music, we could add sounds. That would be really important. We could add like particle effects or an explosion whenever one of the players dies, so he doesn't just disappear off the screen. We can make it look like sparks are flying off the lasers or something of that nature. There's lots more that we could do with this. We could definitely refactor the code and clean it up a little bit. I think I'm going to hang on to this one. I'm going to go ahead and upload it to my GitHub so you all can check it out. Play with it. If you have any suggestions for it, let me know. But I'm definitely going to do another video on this one in the future, and we'll kind of clean it up a little bit. Of course, in the meantime, thank you so much if you've watched this whole thing. I really, really appreciate it. If you want to donate to me, any little thing, any little amount would help kind of offset my production costs. It really takes a long time to put these videos together. If you're unable to donate monetarily, that is totally okay. Again, yeah, check the description below, and I'll have some ways that you can donate to me. But if you would just give me a like, a subscribe, maybe hit the notification bell so you never miss one of my new videos, share it with somebody that you think would get something out of it, that would mean a tremendous amount. And if there's anything else you want to see from any other videos as far as Python or Python Arcade, feel free to let me know. I've also got some more RenPy videos coming up. If there's anything you want to see from those, also feel free to let me know. I'll try to figure out any questions that you might have. And I'm also looking into doing some other videos on JavaScript and some JavaScript game frameworks later on. I've been messing around with Phaser and even 3.js, which is a 3D library where you can render 3D graphics in the browser. It's one of the most ridiculously amazing things I've ever seen. So please stick around. Let me know if you have any questions or suggestions, and I will see you in the next one. Thank you.